Hello everybody and welcome to the video on cones. We're going to be talking about surface area and volume for these cones today. So let's get started and then we'll go into the examples. So let's start with the net. I usually like starting with that. In a cone, you'll notice that at the bottom of the cone we have a circle. That's always going to be true. And then we have the cone part of the cone. And it might be a little bit hard to see just from this, but if you were to unravel that part of the cone, you would end up with a center of a circle. Not a whole circle, but part of it. The radius of this would be this cursive looking L, which is something that you may not know what it is, but you'll notice it's over here too. And this is something called the slant height. Difference between slant height and regular height is if we have this flat surface here, which would be part of the base, the height is going to go straight down and form a right angle with that base, whereas the slant height is going to have a little bit of an angle to it. So the height is what you get just going straight down from the top of the cone, and the slant height is what you get by going down the side of the cone. All right, the reason we need to know that is because both are used in the equations that we're going to be dealing with here. So I wanted to clear that out. Okay, so to find the surface area of a cone, well, part of that is going to be the base, which is the circle that we have. And the second part, which is of course going to give us the part that is the cone, is going to be 1/2 the circumference of the circle times the slant height. So that is the surface area equation for a cone. The volume equation for a cone is actually going to be a little bit simpler. What we have for the volume is 1/3 of the area of the base. Remember, that's what capital B means, and we actually had it in the surface area one as well, times the height. And this is not slant height, this is regular height for volume. So there you have the two equations, the surface area and the volume. So let's try an example out. Find the surface area and volume of the right cone. Okay, let's start with surface area. So we need the area of the base, which in this case is going to be that circle. And we're going to need to add to that 1/2 of the circumference of the circle times the slant height. Now at the moment, we don't have the slant height. That's going to be this one right over here. So we can use Pythagorean theorem to find that out. And we'll have 6 squared plus 8 squared equals x squared. We're missing the slant height. That would be x. So we get 36 plus 64 equals x squared. Gives us 100 equals x squared. Square root of that tells us that the missing side has a length of 10. So that's our slant height. To find the area of the base, we'll use the circle that has a radius of 6, and the base is going to end up being pi times 6 squared, plus 1/2. The circumference is going to be 2 times pi times the radius again, which is 6, times our slant height, which we found was 10. I'll use 3.14 for pi, but I'm just going to enter this into my calculator. So we have 3.14 times 6 squared plus 0.5, which is 1/2, times 2 times 3.14 times 6 times 10. And I'm getting about 301.44 meters squared for the surface area. Volume, at this point, is going to be not too bad for us. Remember, it's 1/3 area of the base times the actual height of the cone. So we're going to have 1/3 times pi times 6 squared times the height, which is 8. For 1/3, you could enter it a number of ways. I would recommend just doing 1 divided by 3 and hitting enter on your calculator, and then multiplying the rest. So that gives you 0.3 repeating, times 3.14, times 36, times 8. So, and this will not always happen, but it is happening this time just out of circumstance. It turns out here that the volume and the surface area are the same number. It does not happen all the time. One difference is that this is going to be meters cubed, because since we're dealing with volume, remember we're dealing in 3 dimensions here. So that means that we're going to be dealing with meters cubed. All right, first example out of the way. Second example. Find the volume of this solid. Okay. Well, since we're dealing with volume, it doesn't need to, we don't really need the slant height. We just need the regular height, which is given to us, and the radius, which is also given to us. So V equals 1/3 area of the base times the height. So that'll be 1/3 times 2.2 squared times pi. And then the height is 4.5. So again, we'll do 1 divided by 3, get our 0.3 repeating, then do 2.2 squared times 3.14 times 4.5. And we find out that the area here, or the volume, I'm sorry, is about 22.80 centimeters cubed. So that one was pretty simple. You just have to realize that this here is the height. Remember, the height is going straight down from the top, making a right angle. So there's that. All right, flipping over to the back, we're going to see 2 examples that are a little tougher. So here we have a right cylinder, which is going back to our last video, with a radius of 3 centimeters. So we know that that's 3 centimeters for the radius, and a height of 10 centimeters. Has a right cone on top of it with the same base and a height of 5 centimeters. Find the volume and surface area of the solid. So, for the surface area of this solid, what we're going to need is to find all the parts of the surface that are still showing. So for the cone, notice that that circle, the circle part of the cone, is being covered up by the other circle from the cylinder. It's not part of the surface anymore. So all we have left is this cone part. And remember, the formula that gives us the cone part is the part that says 1/2 of the circumference of the circle times the slant height, which we do not have yet. From the cylinder, we're getting different parts of the surface. We have one circle on the bottom from the cylinder, so that's going to be an area of the base. But then additionally, we have this rectangle here. And remember, the formula for that rectangle is going to be the circumference of the circle times the height. So those parts added together are going to give us our surface area. We're going to need to do some calculations. We're going to need the slant height. So part of what we can do is use the Pythagorean theorem to figure out what the slant height is. So we'll have 3 squared plus 5 squared equals x squared. That's 9 plus 25 equals x squared. 34 equals x squared. take the square root of 34, and we get 5.8 or so. So that is length of 5.8. And we'll just include the circumference and the base in our calculations. So our surface area is going to be 1/2. Radius of the circle is 3, so circumference is going to be 2 pi times 3. Slant height we just got was 5.8. So we've gotten this part. Plus, the area of that base, which is the circle, is going to be pi r squared. So pi times 9, because 3 squared is 9. Plus the circumference again times the height of, in this case, the cylinder. So it's going to be plus 2 pi times 3 times 10. So we have to enter all of this into the calculator then. 0.5 times 2 times 3.14 times 3 times 5.8 plus 3.14 times 9 plus 2 times 3.14 times 3 times 10. Lots of stuff to enter in, but in the end you should have 271.30 centimeters squared. Volume is going to be a little easier, because with volume there's nothing hidden. Everything that's there should be included. So for volume we have two shapes that we need the volumes of. For the cone, remember the volume formula is 1/3 base times height, and this is only going to be the height of the cone, which is 5. And then for the cylinder, we're going to add in the area of the base times the height. Remember, this height is just the height of the cylinder. So we're going to have 1/3. Area of the base is 9 pi, same as above, pi times 3 squared, times the height of the cone, which we know is 5. It was given to us in the information. Plus that base again, 9 pi, the area of it, times this time 10, because that's the height of the cylinder. So 1 divided by 3 gives us our 0.3 repeating, times 9 times 3.14 times 5, plus 9 times 3.14 times 10. And that gives us about 329.7 centimeters cubed. I think you've seen a lot of the calculations at this point, so I just want to give you the setup of this one, and then I'll let you get to start working on your assignment. Here, you'll notice that we're given this angle. We don't know the radius yet, but we know the height. What we'll want to do is we'll want to use trig to figure out the radius, and then once we have the radius, we'd be able to find the slant height by using Pythagorean theorem. So the setup that we would have here is, right now we're looking for the radius. From this angle, that's the adjacent side. Here's our opposite side. Adjacent and opposite means we're going to use tangent. So we'll have tangent of 65 equals 16 over our radius. Best way to solve this would be to turn tangent into a fraction and then cross multiply. So we'll have 16 equals tangent of 65 times r, and we'll divide both sides by tangent of 65. So then we'll know what our radius is, and our radius is going to be 16 divided by tangent of 65. So radius is about equal to 7.46 feet. So once you have the radius, these problems are kind of like the other ones that you've seen, and I don't want to bog you down with more examples if you're getting it. And if you're not getting it, just rewatch the other ones on the video. The only new thing about this one is the trig. So that takes us through the examples and figuring out some of these volume and surface area problems for this. So thanks for watching, and see you in the next video.